Okay, today's integral is the integral from 0 to pi over 2 of 1 over tangent of x to the power of square root of 2022, all plus 1. And now this looks really ugly. This is actually a 1-second integral, and the answer is just pi over 4. But how do we know that? So this is actually using a trick called King's rule, which I'm going to show you today. So the first thing we're going to want to do is we're just going to turn it all into sines and cosines. So we're going to multiply everything by cosine to the power of the square root of 2022 of x. Once we have this, what we're going to do is use substitution. We're going to let u equal pi over 2 minus x. That will mean our x is equal to pi over 2 minus u. That will also tell us that du will equal negative dx, and now we could actually plug this stuff back into the equation. So pi over 2 minus pi over 2 is 0. Pi over 2 minus 0 is pi over 2. Now our bounds are changed. Now if we do the actual integral part, we will have cosine to the power of square root 2022 of pi over 2 minus u now over sine to the root 2022 of pi over 2 minus u plus cosine to the root 2022 of pi over 2 minus u. And then this will all be du, but don't forget it's a negative, du is equal to negative dx. We have to pull a negative sign out to the front. And now this looks really ugly, but we could actually simplify this quite a bit right now. So our bounds are kind of backwards, but with this negative we have here, we can switch those bounds back to normal. So it'll still be from 0 to pi over 2. And using our two formulas up there, sine of pi over 2 minus x equals cosine x, and cosine of pi over 2 minus x equals sine x, we can clean this section up a bit, and we will have cosine to the root 2022 of u, or actually no, it's sine of that. Sine to the root 2022 of u, my bad, over cosine to the root 2022 of u plus sine to the root 2022 of u. And then du. Okay, so I just cleaned up the board slightly, and so what we're going to want to do first from this point is we're going to just let our original integral equal to I. And because these are all the same integral, we're working with it algebraically and stuff, but this is still just I. So this integral is also equal to I, and this integral is also equal to I. Now another rule we're going to want to apply here is that if an indefinite integral, you could call the variables whatever you want. So even though these are all u, I'm going to switch these all back to being x. From here, we're going to notice that this integral I and this integral I, they both have the same denominator. So what we could do is we can add these two integrals together. So we will have 2I equals this integral plus this integral. And an integral property we know is that adding the integrals, if they're the same bounds, we're just going to be adding the inner terms. So it'll be the integral from 0 to pi over 2 of cosine to the root 2022 of x over sine root 2022 x plus cosine root 2022 of x. All of that will be added to sine of root 2022 of x. And then over the same denominator, I'll just write that down. It's starting to get a little messy here again, but we have everything written down, so I'm going to clean this up. And what I'm also going to do is notice that these are both the same denominator, so we can write it all over the same denominator in adding these two terms. Okay, now that we've combined the denominators, what we can notice is that adding the two integrals together, so we will get cosine to the root 2022 of x plus sine to the root 2022 of x. That's exactly what we have in the denominator. So all of this just cancels, and this is just going to be equal, so that makes 2I is equal to 0 to pi over 2 integral of 1 dx. That means 2I equals x from evaluated at pi over 2 and 0, whatever. And so that will mean 2I equals pi over 2 minus 0. And so 2I equals pi over 2. And that means I equals pi over 4. And that is how we get pi over 4 in a 1-second answer. Now, if you guys wanted the general form for King's rule, it's going to be the integral from a to b of f of a plus b minus x over f of x plus f of a plus b minus x. and that is going to equal b minus a over 2. And this worked, and like how this worked with us is we had f of x was equal to sine of x, and then f of a plus b minus x was equal to cosine x. And that's because a plus b for us, a was 0 and b was pi over 2. So pi over 2 minus x. Sine of pi over 2 minus x is cosine x. So that's where we got our sine x, and cosine x here. And so that perfectly fit the form of this equation. And that is how we were able to use King's rule. As for this part here, our b was pi over 2 and our a was 0. So we had pi over 2 minus 0 over 2. And that's how we got pi over 4. So that is how we use King's rule for our integral. And this is the general form for King's rule.